Afternoon, sir. Hello?
Happened to you? Yeah,
Sir,
late.
the internet, teacher. Sir, the internet.
You always blame my internet. Okay, let us make a start. If it's the internet problem, then you probably have to upgrade your computer or laptop, increase the RAM. That's what I did to my computer. Now I have less problem. Okay, probably have to increase the RAM or change the hard disk to SSD. Take the computer shop and ask them what is the problem. Okay, let's try to start now. And you see how it goes. May give you a short break for 5 minutes after, because we still got 2 topics to cover. So rather than cover the whole topic, we break it into 2 halves. Okay.
Okay.
Anything that you want to ask?
No.
So have you been revising your second term or not?
Yes, sir.
You're supposed to be asking question already. Still not asking any question. You cannot study on physics. You have to learn the basic thing, and then you have to do the problem, solve the problem. That's how you force it in. Same with maths. You study, you either hit or miss only. Okay, let's go to 23.7 polarization. Right, page 187. State that polarization is a property of transverse wave. That's a syllabus. Explain polarization of light obtained by reflection or using a polarizer. Use Brewster's law, tangent theta b equals to n. Use Mahler's law, that's the Mahler's law. Okay, let's make a start. Polarization. A wave is plane polarized if its vibration is in a single plane. Like it's showing a diagram. Vibration is on single plane. In mechanical wave, example, a rope. This can be a rope. A rope vibrating in a vertical plane. You move up the rope, up and down. The wave pass through a vertical slot. So if it's plane polarized, it will pass through the vertical slot. If it's plane polarized, vertical. The slot is the polarizer. Right? We call the slot the polarizer. The wave is said to be vertically plane polarized. Right? It's called vertically plane polarized.
The screen.
And this is the polarizer.
Hello?
Hello?
Yeah.
Oh, I think he was a bit late. So it's now with me now. Okay, thank you. Bye-bye. Yeah, what are you trying to say? Anything? Very soft. Anything that you want to say? Okay or not?
Okay. Now okay, now.
You better get your computer to go and check your laptop. Go to the...
No, it's not my laptop, it's the Wi-Fi.
I used to have a problem like you. You can see the internet is very slow. Can't get your WhatsApp.
It's not my computer, it's the Wi-Fi problem. Always it happens like this.
If you use your smartphone, I don't think you have a problem. If you have a laptop, because the memory is not enough.
That's how I'm using hotspot.
Then you shouldn't have problem on smartphone.
Even smartphone unstable just now and then reconnected. Now it's
Okay, let's carry on. Right? The slot is called the
yeah.
polarizer. The wave is said to be vertically plane polarized. Right? We can use another one. Right? When a second polarizer called the analyzer is rotated through an angle of 90 degrees, no wave is transmitted. In this case, right? If you rotate it, the same. If the slot is parallel, then you have the same wave passing through. That's why we call analyzer. Because by rotating it to 90 degrees, the two slot at 90 degrees, nothing will come out. Then we know it is polarized. Okay, this is plane vertically polarized. If it can still pass through, then it's not vertically plane polarized. Right? It's unpolarized. A polarizer is to restrict only one plane as all, one plane of vibration. So you got two perpendicular, it remove the other. Nothing will come through. Right? What is polarized? It's an artificial crystalline material which can be made in thin sheet. So instead for light, instead of a slot, we use a polarized. It has the property of allowing only light waves due to vibration in a particular plane to pass through. That's the property of the polarized. It only allows light waves in a particular plane to pass through. It means as it passes through the polarized, it's plane polarized. It's used as a polarizer for light. Right? Remember, light is a transverse wave, as we show, vibration of electric field, vibration of magnetic field. Right? If it's plane polarized, if it's a transverse wave, it can be plane polarized. Longitudinal wave cannot, right? Because longitudinal wave is the vibration is parallel to the direction of motion. Only when it's perpendicular to the motion, or we call transverse wave, they can polarize it. Light wave, just like electromagnetic waves, consists of vibration of electric field. Okay? That's the electric field shown in a diagram. And the magnetic field, which are mutually perpendicular to each other. That means the electric field and magnetic field vector are perpendicular to each other. So only transverse wave can be polarized. Okay, so that is a shorthand of representing your electric field vertically, and the red one is your magnetic field. A wave in which the plane of vibration is constantly changing is called unpolarized. Right? And that's how we show it. The plane of polarization is constantly changing. So the waves from a lamp are unpolarized, right? From whether a light source that you have fluorescent tube or bulb or lamp, they are unpolarized. That means it can be any direction. We can represent the intensity as vibration in two perpendicular directions. And you can show it. Right? If the wave is going in, then we can represent two perpendicular directions. The intensity in two perpendicular directions. If the unpolarized wave has intensity I, each component has intensity half I. Right? So each of these components half I. Okay, any comment so far? So if it's plane polarized, basically when you use a polarizer, you remove one component, either vertical or horizontal, or it can be at an angle. It doesn't have to be vertical. If the intensity of unpolarized beam is I, this one is I, the intensity of the transmitted beam through the polarizer, this polarizer, is half I. Right? This I, this will be half I. because you remove one component already. Then if you pass through this slot, it still be half I. When the beam is directed to another polarizer, right? This is a polarizer. We call it analyzer because it helps us determine whether the light wave is polarized or unpolarized. Right? If it's parallel, the wave pass through. When the axis of the polarizer, this one, axis of analyzer is perpendicular. These two slots are perpendicular. Of course, polarized doesn't show you the slot, but this is you just imagine it to help you understand. Perpendicular polarizer, no light will pass through. That means you see nothing. Darkness can pass through the observer see no light through the analyzer. So this will be 0. Okay. Mahler's law. If the intensity of unpolarized light I, the intensity of transmitted through the polarizer is I0. Right? This is I, this is I0. I0. Right? This is polarized. Right? Remember, we have to work with amplitude. If the amplitude of light incident on the polarizer is A, right? This I0 is A, intensity is I0, amplitude is A, then I0 is proportional to amplitude square, or I0 equals to Ka square. K is your constant. When the axis of an analyzer is rotated through theta, remember that's the axis. That's the axis. They rotate the axis through an angle theta. The amplitude of light is, right? Now amplitude is Y. Right? Just resolve it. This is A is here. So at the angle theta, it becomes A cos theta. The other component that's perpendicular is removed. Then your I1, which is passing through the analyzer, I1 is K, right? Amplitude, this is amplitude, square that. So your Ka square is I0. Can replace I0. Okay, so that is your Mahler's law. It is applied to plane polarized light. Not unpolarized light, but plane polarized light. And it's given by this formula. Right? Remember, this is polarized light. Okay, in this case, what is I in terms of I0? What is this I in terms of I0? Yep. Yep. What's the answer? Can
I
give
not
me the
cos
answer?
square theta.
Say again.
I not cos square theta.
No, we are not paying attention in class. This I0, this I1, then they are related. This equation is only to a plane polarized. Now I'm asking you about I0 and I. How are they related? You have two components. Each component is I0. So component is 2I0. That's all. The polarizer allow only one component to pass through. That means half will pass through only. Okay or not? Okay, we are just using this formula and draw the graph of intensity against angle. Okay, let's understand the graph. This is the equation. At 0 degree, remember this is a cos graph. You square the cos graph. 0 degree is maximum, I0. And then it decreases. You see from the graph that it decreases. Right? With 90 degrees, becomes 0. Right? If it's your cos graph, it will go below. But because you square it, becomes positive. So as you increase further after 90 to 180, you increase again to the maximum. Right? And then you increase further from 180 degrees. 180 degrees is here. It decreases to 0 at 270 degrees. And then increase again to maximum at 360 degrees. Okay with that? The cost graph is going that way. This way. Going down, going up again. Refer to your STPM, which I've gone over with you. Stop me if I'm going too fast. Okay, polarization by reflection. There's your polarized sunglasses. Polarized sunglasses will cut out the reflected glare, the reflected light from roads, because the reflected beam is partly or totally polarized. We will learn into that in a while. Right? The reflected light is usually partly or totally polarized. So it's partly or totally polarized. You pass through the polarized sunglasses, half of it will be gone. This polarization occurs when light is reflected from any non-conductor of electricity. So wherever light is reflected from a non-conductor of electricity, it is polarized, partially or fully. Right? We'll see in a while how it can be fully polarized, it can be partially polarized or fully polarized. Whether the polarization is total depends on the surface and the angle of incidence. Okay, let's go to this is your glass, this is your air, this is your air glass boundary, this is your incident rate, that's your angle incidence. When light is incident on a material, for example, glass, that's your glass. Part of it is reflected, and part of it is reflected, part of it is reflected into the material. Right? This is reflected. There's an angle of reflection, same as angle of incident. This is the refracted light ray. This is your R. So the thing you need to remember is angle of incident equals to angle of reflection. And the refractive index of glass is your sin R, sin I. Always the largest value, you are at the smallest value, sin R. Okay. Reflection and refraction. The refracted light is partially horizontal plane polarized. If this is very expressive, it's in your book. That component of pass through. This one vertically one is partially polarized at an angle I. And then this is your angle R, angle of refraction. This is also partially polarized, this one. Only this component of pass through. The reflected light is this one. Reflected light is plane polarized, is vertically plane polarized, partially only. Partially vertically plane polarized. Not complete yet. Okay. Brewster's law. Brewster's law. Brewster found that at certain angle of incident P, called Brewster's angle, right? Your syllabus, instead of call it P, we call it theta B. Same thing, right? P and theta B is the same thing. Or we call it polarizing angle. The reflected ray is fully plane polarized and the direction perpendicular to the plane of incident and the, sorry, must have pressed something wrong. Okay. And the reflector one, this one, is fully plane polarized in the plane of incident. Okay, that is the plane of incident, the pink color surface. Right? plane of incident. So this is in the plane of incident. So this one is removed, or this one is going in and out. This one is going in and out. So the in and out one is the one that pass through at Bruce's angle. Right? We will determine the while. Whereas the reflected ray, this one is removed. The one parallel to the plane of polarization will pass through. Brewster's law states that the reflected and refracted ray are fully plane polarized if your that angle, tangent of this angle, equals to your refractive index of glass or the material, this material. N is the refractive index of material, theta B is the angle of incident. Right? Sometimes I use P, sometimes I use theta B. Any comments so far? Memorizing work, nothing much. Okay, sometimes we represent vibration in the plane of the paper as lines. This is plane of the paper. Right? This is a whole plane, paper there. This is the whole paper, that's a plane. So we draw a line. And if it's going in, we represent a dot. In and out, vibration in and out, represent as a dot. At Bruce's angle, the reflected ray and the refracted ray make an angle of 90 degrees. This one, we are going to show in a while. Right? At this angle theta called Bruce's angle, the reflected ray and the refracted ray make an angle of 90 degrees. Let's show it now. Derivation. Right? Our refractive index. Okay now. Any comment? Okay. So we take the angle of incident, sin P over sin R. This sin R. And then Brewster's law tells us tangent P equals to N. Yeah, that's Brewster's law. So now we can replace these two are equal. Right? Sin P over R equals tangent P. Tangent P, we can replace it with sine and cosine. So it's sin P over cosine P. Sin P and sin P can cancel off. We cross multiply, we got that. Right? Cross P, remember they are 90 degrees. P and R is 90 degrees. Right? We can write as sine 90 minus P. Right? As our, that's our P. This is our R. This is our 90 degrees. So from here, we can write that our R equals to 90 minus P, or R plus P is 90 degrees. Okay, anything not clear?
So far, okay.
Okay. The electric field vector in the incident ray can be resolved in a two mutually perpendicular direction. One in the plane of incident. Right? This is the surface of the paper, of the surface of the screen. It's called your plane of polarization. Right? Vertical. So this is your EI. And the other perpendicular, ER. Going in and out, the dot is ER. Usually we deal with amplitude, or we deal with electric field, not magnetic field. And then after that, we convert it to intensity. EI is the reflected, ER is the reflected. Right? EI is the reflected, ER is the reflected. Okay, your worksheet. If you haven't written it down, you can write it down. What is plane polarized? Yep. If you have written it down, you should be able to tell me what is plane polarized. Yep. Means that you have not been paying attention in class. Too comfortable. Everything done for you and record for you. Yep. What is plane polarized? A wave is plane polarized if its vibration is in a single plane. Okay? State Mahler's law. Yep. What's Mahler's law? Intensity of polarized light right? If you don't know, write down. Intensity of the polarized light, on entering a polarizer is I0. The intensity of transmitted beam to the polarizer when the axis of analysis is rotated to theta is given by this equation. That's all. These are all for you to memorize. What is a polarized? Yeah. You are not paying attention in class. How are you going to go forward? I don't know. Memory will only. You never write down. Write down. Polarized is an artificial crystalline material which can be made into a thin sheet. It has a property of allowing only light waves due to vibration in a particular plane to pass through. Write down, write down. It won't help you if you are lazy. All these are basic that you need to know. Okay, have you copied all? Talk to me, talk to me. If you need more time, tell me you need more time.
Oh, done, sir.
Okay, we are done. Take Bruce's law. Right? These are important laws that you need to remember. Right? That's why you can't remember because you don't bother to write down. You're too comfortable because I record everything for you. Bruce's law states that the reflected and reflected ray are fully plane polarized if your tangent P equals to N, where N is the reflective index of material and P is the angle of incidence. That's all. Okay, write down. Okay, we have completed. So let's go and do some question before I give you 5 minutes break. Okay, need more time?
No, no, I'm good.
Have you copy?
Yeah.
Okay, let's do some problem then. Basically, that's all. That's all for this topic. Okay, you got one more to do. This one. Find for me the polarizing angle for glass or reflective index 1.54 using Bruce's law, number 43 in your worksheet. What is the polarizing angle or the angle of incidence?
57 degrees.
Okay, good. So all these things that you need to remember, our latest one is here. This one, Bruce's law, Mahler's law. Okay, let's try to Checkpoint 23. .7. Okay, tomorrow we'll discuss this one. Focus 23, 1 to 20. Structure 1, 1, 2, 4, 6, 7. Essay 1 and 2. Right? So it means that you have no choice tonight. You have to do some homework. Two pieces of polarizer P and Q are arranged along the same straight line. That's the same straight line. With their axis of polarization vertical and parallel. These axes are vertical and they are parallel. A beam of non-polarized, this is non-polarized light of intensity I, is directed at the polarizer P. As a polarizer, that's an unpolarized light. Polarizer P is rotated to 360 degrees about its axis, but polarizer Q remains constant. Right? This remains constant. Is rotated through 360 degrees. Describe how the intensity I1 of light transmitted through P changes. Right? You're interested to know I1. This one. Not I2, I1. Okay. Should be? As you rotate P, how does I1 change with angle? Can? Right? Polarizer P is to remove one component. So one component will still pass through. It doesn't matter the angle. Right? If it's unpolarized, remember it is not always vertical and horizontal. It can be at an angle. But the polarizer is to remove one component. So you still got half a component going through. The intensity decreases from maximum. There's something wrong here. Sorry, done something wrong here. Intensity decreases from let me check. I think the answer is wrong. Yeah, answer is wrong. Sorry. Sorry. This one is supposed to be part B. The intensity passing through to P is intensity is half I. The polarizer removes one of the
So you put them this teacher.
remove, sorry. Yeah, I'm getting very bad. Right? So basically, there's two components. One, if you take one vertical, one horizontal, but remember, it doesn't have to be vertical, but they are always these two components. Each of them is half I. And each of them are perpendicular to each other. So the purpose of the polarizer is to remove half of them. That's all. So the other half will pass through. Doesn't matter about the angle. So the intensity is constant. Can? Right? Intensity passing through P is half I. Polarizer remove one of the component, so the intensity is constant. Okay, half I all the while, doesn't change. Yep. Any comment? Anything not clear? The other one is just memory work. Sketch a graph to show how the intensity I2 of light transmitted through polarizer Q varies as polarizer P is being rotated. That's all. Memory work. Any comment? Anything
No.
not clear? Sure, you copy down whatever you don't know. Don't depend on always recording to help you. Copying down is a way to force yourself to remember. Okay? Need more time?
No, I'm good.
Okay, all right, let's go to number 2. A beam of non-polarized light of intensity, right? This is I naught. Doesn't matter. You can call it I naught, you can call I1, I2, doesn't matter. Don't get confused. Understand what it does. It's directed at polarizer P and Q as shown in the figure. The polarizing axis of P and Q are perpendicular angle to each other. State in terms of I naught. Right? Remember, I naught is this one. The intensity of light passing through P. Yep. What's the intensity of light passing through P? What does the polarizer do? Remove half the component. The intensity is represented by two perpendicular components. So you remove half, what happened to the other? What happened passing through? Half will pass through. Right? So if they are perpendicular, nothing will pass through. You remove the other half. Right? So the vertically plane polarized will pass through. That's why it's half I naught. This is I naught. So the one vertically plane polarized will pass through, perpendicular, parallel to the axis. So if perpendicular, nothing will pass through. Keeping the arrangement of P and Q unchanged, explain how you would arrange another piece of polarizer R such that the intensity of light transmitted through Q is different from the answer in A2. You don't want this to be 0. How do you put another polarizer there? Yep. Yep. Insert a polarizer R here. Place the axis of polarization of R at an angle to P. Right? You don't place it vertical as parallel to P. Place parallel to P, it will just pass through and then it will be blocked. I think of the polarizer R, right, in between P and Q, and changing the axis of rotation. Right? This is vertically plane polarized. So you put R at an angle to the axis, to this vertical axis, then only the one parallel to the axis will pass through. Can or not? You understand or not? I don't think you understand what is happening. Okay, I think I will give you 5 minutes break and then try to finish the other topic. Then tomorrow we'll carry on 3 to 5. I think there are still, rather than carry on since you are, still 3 to 5. So you got quite a lot of homework to do. Number 3 to number 5. And then the focus question. Okay or not? 5 minutes break.
Okay.